Hello learners, welcome to another module of Introduction to Data Science using AI Assistant Tools. I'm Dr. Vishwas Kukreti and we are learning how to visualize our data. So we quick recap where we understood in the few previous modules what data science is, and then we set up our different tools. In the next module we understood descriptive statistics where we understood averages, median, mode from numbers. In the previous module, we also understood the basics of data visualization, how data visualization is important, and few bar charts, line charts, and histogram. Today, we will work across more such data visualization tools. So, if you remember, we were learning about line charts and histograms, and we had made an important distinction how histograms are very different from your bar charts. Then we also understood what a line chart is. Today we will begin with another kind of chart, which is a pie chart. So a pie chart is a very different kind of data visualization. It shows parts of a whole, or a pie, consider a cake. So if you divide a cake into different sections, you can get different sizes of your pies. A pie chart is something which shows parts of a whole. Consider a big circle divided into slices. Bigger the slice is larger the percentage. So if you would see on the screen, it shows a visualization which says pie chart of populations of English native speakers. And it's not tough to see that your eyes are taken to the biggest chunk of the pie, which says USA. And then you can see you have another countries, UK, Canada, others, and Australia. And instantly you can see that USA has the most number of English native speakers, followed by UK, Canada, then Australia is last. So you would see all of these percentages are 100%. For example, if there are 100 native speakers, USA has the majority of them. Let's say 65 speakers are from USA. The rest of it's distributed among different countries. So a pie chart shows a percentage population. Now when to use a pie chart? You can use pie chart for different data visualization requirements. For example, if you are showing a budget breakdown, now if you are doing budget or rationing for your home's income, you can, for example, say you spend 40% on food, 30% on rent, savings 20%, and the rest is 10%. Then the entire 100% is your income, and the different chunks show how you spend your money. Similarly, if a farmer uses to show how much he uses the entire farmland area to grow different types of crops, for example, he can say he grows 50% on the land area wheat, on the rest of the 30% he uses rice, and on the rest 20% he grows vegetables. It's essential to know that only use a pie chart when all the parts add up to the entire 100%. So, for example, let's see an Indian example where we are dealing with family expense. So, you would see we have allotted food a budget of 8,000 rupees. For rent, we have kept 5,000, education 3,000, transport 2,000, and savings again rupees 2,000. And we want to use a pie chart to show which thing uses the biggest chunk of our earning, right? The use case is pretty simple. Families can see where most money goes each month. If you would see, we can easily use ChatGPT to create a prompt and then run that code. And it would easily show, a pie chart can easily show that 40% of your income goes to your food. So this is not only more visually aesthetic, but it also tells you how different things are related to each other. So you would see you only pay 25% of your income as rent and 10% on transport. So just looking at one picture, you can get the entire gist of your expenses. Now this is where data visualization really shows up over a table. Consider a case where these budgets were not divided into not only 5 but let's say 15 categories. It would have been very different or difficult for you to remember which part or which expense goes where. Whereas it is very simple to look at a graph and understand which is the most expensive rationing, or which part takes the lowest expense. So this is the use of data visualization in your data science journey. Now If you have understood a pie chart, we will move on to something which is called a scatter plot. Now, a scatter plot is a very unique kind of data visualization. Earlier, we were interested only in the dynamics of a single variable. For example, in the previous pie chart example, we were talking about family expenses, or in the line chart, we were tracking how many runs does a team score over different overs. Or we can see, or if we talk about rainfall in a line chart. But now things are getting interesting and we introduced something called a scatter plot. So a scatter plot is unique because it shows the relationship between two different things or two different variables. We have one variable on the x-axis and another variable on the y-axis, and each dot represents one observation. And what's the use of a scatter plot? The use of a scatter plot is it helps find if two things are connected or not. For example, if you see on your screen, we have two axes and two different labels. So each of these x and y coordinates form one data point. So the plot says scatter plot for quality characteristics. On the x-axis we have process input and on the y-axis we have our quality characteristics. Both of these data points coordinates when get together create one scatter plot. And if you would do a intuition thinking over this, you can also see the trend is decreasing. So it says as the x-axis or the process input increases, the quality characteristic, let's say x decreases. So if you would see, this is very useful for creating a relationship from two different variables. Now, when to use a scatter plot? So scatter plot is useful when you are trying to relate two different variables. Does studying more hours lead to better marks? How will you answer this question? Or do taller plants produce more fruit? Or is there a connection between rainfall and crop yield? Let's get back to our previous example and ask the question, does studying more hours lead to better marks? Now, to ascertain this relationship, we need both hours you study and the marks you get. Right. So, for example, if our data has 20 students, we need their student study hours and their marks. On one axis, we can use the study hours, and on another axis, we can use marks. Now, what will the scatter plot tell us? The scatter plot will show us the relationship between students who study more and how much marks do they get. For example, a scatter plot might show that students who study more tend to score higher, and which is logical and intuitive. So, a use case could be a teacher can understand if study time affects performance. So, here what you can see on your screen is the relationship between study hours and the marks obtained. So, you can see it is a very linear relationship. It increasing in one dimension, and we can spend a minute to understand what this particular slide means. So, you would see the x-axis shows different labels and the label is study hours. So, it shows the frequency study hours of different and the marks obtained by 20 students. So, you can see the first student who studied only 1 hour got lesser than 40 marks. Then we have certain students who spent between 2 to 3 hours studying, and the marks they got were between 40 to 45 or 46. Similarly, we had students which studied between 3 to 4 hours, 4 to 5, similarly 6 to 7, 8 to 9. Now, you would see this relationship is increasing. As the number of study hours increases, the marks obtained also do increase. For example, the students who studied between 8 to 9 hours received marks between 75 to 80. Now, this would prove our hypothesis that students who study more tend to get more marks. Now, you will see how easy it is to use data visualization tools. Using a pretty simple data visualization tool like a scatter plot, you were able to validate your hypothesis. So this is the power of data visualization tools. Now you can use scatter plot even in multiple axes. However, we will stick to 2 dimensions for our sake of learning. Now let's begin something which is called a box plot. Now what is a box plot? So when we were talking about histograms, we encountered a word distribution, and we said distribution essentially means how data is scattered. And you also understand the terms minimum, maximum and median. So if you remember, the median term is the value below which are 50% of the data points and above which are the rest increasing 50% of data points. So this shows how the data points are scattered across the minimum, maximum and the median value. And the box shows where most of the data points are. The box plot also has lines, or it's also called whiskers, which show the range. Now we'll also understand range in the coming sessions. So essentially a box plot shows you multiple values with just one visualization. For example, if you can see on your screen, you can see a box plot, whiskers and a scale. So let's analyze this particular graph. It shows a box plot which shows the data is scattered between somewhere 3 to 9. And the whisker which goes down is at 2, and the whisker which goes up is at 15. Now if you would see the data, our data is scattered across between 2 to 15. So our data goes something like this. It's 2, 3, 4, 5.7, 6.5, 7.2, 12 and 15. Now we see the whisker which is on the lowest side shows 2. So the whisker, one of the whisker which goes down, or the which is on the left hand side, shows you the minimum value, whereas the whisker which goes on the right hand side shows you the maximum value. The maximum value here is 15. Now let's focus on the box. So the box has 3 numbers. So it says lower quartile, median and upper quartile. Whereas we will understand what quartiles and interquartile range are in much more detail in the coming sessions, let's quickly understand what quartiles are. So essentially quartile means dividing your data into 25% parts. Dividing, or 25% means into 4 equal parts. So you would see your box contains the lower quartile, which means it contains the values which are greater than 25%, and the upper quartile shows values which are lower than the 75% range. And there is a line in between the box which shows median, and as we remember, median is the 50% mark. So the box plot shows multiple values through just one visualization. So the first value it shows is minimum, then it shows the 25% mark, then it shows the median which is the 50% mark, then it shows the upper quartile which is the 75% mark, and then it goes on to show which is the maximum value which is 15. Box plot can also denote outliers or something which is far across the distribution or scatter range, but that's for some other session. So the box plot is a very useful data visualization. Now the question arises, when to use a box plot? You can use a box plot when you are comparing salary ranges across different cities. So you want to understand the minimum salary, the maximum salary or the median salary you get. If you remember, we talked about mean and median being used different in different cases. You're not interested in a mean salary, rather you're interested in the median salary, because the mean salary can be affected by outliers or certain data points which do not fall into the distribution. A box plot is also very useful when you want to understand exam score distributions in different schools. Now it's also essential when you're trying to find outliers or certain unusual values. So certain unusual values which fall across very different from the distribution of the box plot, you can term those as outliers. So if you would see, one single data visualization is useful for your comparison and also doing your statistical analysis. A box plot is a very useful tool in your arsenal. It's a multiple varied tool which you can use in different places. Now let's get one example of using box plot. So we are interested in understanding daily rice prices for a month in Punjab, UP, Bihar in the state of Tamil Nadu. Now what would our box plot show us? So our box plot would show which state has stable prices and which has variation. So what is the use case here? The use case is government can identify states with price instability in rice. Now let's get these visualization. So you would see we have the states on the x-axis and we have our box plots plotted over them. So you would see we have different 4 box plot. So you would see Punjab has one, UP has one, Bihar has one, and then Tamil Nadu has one. Now we did the analysis of a box plot and let's understand what do these box plots show here. So if you would see for the Punjab region, it shows you the median. The box shows inside the box the value which is 40.3 shows you the median price of rice. Similarly, you can have compare median values for rice across UP, Bihar and Tamil Nadu. And it's easy to see Tamil Nadu has the median which is the highest across all different states. And also you can see the minimum price of rice for Tamil Nadu is the maximum for Punjab. Also you can see Bihar has the lowest minimum price of rice and the maximum rice is much above than what UP's median price is. So you can see you can do a comparative analysis across different states using simply box plots. So box plots not only tell you about distribution or the data scattering across a single state, but you can do a comparative analysis across different states. And not only does it tells you the median value, it also tells you how are the prices scattered across different states. So for example, let's understand this also. You would see for Bihar, the median or the box plots box is more towards the minimum side. So the whisker for the box plot is shorter on the minimum and greater and larger on the maximum side, which means the median values tend to scatter around or go towards the minimum value for the state of Bihar. Similarly for Punjab. However, you would see for Tamil Nadu it's quite equal. So it follows something. So 50% in 50% cases the prices are greater than 50%, and rest these are equal. So a box plot is useful not only for a particular variable analysis but also doing a multiple variable analysis. Now I encourage you to do certain practice activities. So the first is for bar chart. Now the scenario is something like this. So a rural school has certain number of students. In class 6 it has 42 students, in class 7 it has 38, in class 8 it has 45 students, in class 9 35, in class 10 only 30 students. Your task is to use ChatGPT to generate code for a bar chart and then run it in Colab. If you remember, we had already provided a prompt which you can use to run a bar, which you can use to create a bar chart in ChatGPT and run that code on Google Colab. So I encourage you to use that prompt to create a bar chart for this particular practice activity. Similarly, you can also do a practice activity for an histogram. The scenario here is something like this. So a health worker has recorded heights of 25 children in centimeters. So we have different numbers, 25 numbers to be exact, of heights of 25 children. So it's 140, 145, 142 and all the way from to 149 and 143. Your task is to create a histogram to see the height distribution. And then once you have both the bar chart and the histogram, I encourage you to do an analysis and how things are different for the bar chart and the histogram. Now, there are some troubleshooting tips which you might encounter. If a chart does not appear, the first thing is to check if you have clicked the play button. Do not forget to execute your cell. Once you copy the code from ChatGPT and paste it in the Google Colab, you need to execute the code for it to generate the chart. Do not forget to hit on the play button or execute that code cell. Similarly, another salient point is make sure you pasted code in a code cell and not a text cell. As we have already mentioned in the previous modules, Colab provides you with two different kinds of code cells. So one is a text cell and one is a code cell. If you mistakenly paste your code in a text cell, it won't execute. So it's very necessary that you paste your code in a code cell only. Now, if you get any error message, do not get worried. You copy that error message and paste in ChatGPT and ask it to debug that error. The AI assistant tools are smart enough to debug any error they have and create the right chart. Now, if your chart looks strange, do check if your data is correct or have you made any mistake while pasting the data. If you think the chart labels are not clear or the font size are too small, you can go back to your AI assistant tool and prompt it accordingly. Never be afraid of asking the exact details you want. So, for example, you can ask ChatGPT to make the chart labels clearer, or ask it to increase the font size of the title, or increase the font size of your labels on X or Y axes. Now, there is a challenge activity for you all along with the practice activities. So, the scenario here is something like this. So, you are helping a farmer analyze monthly milk production. In January, the farmer had 250 liters of milk. In February, he had 280. In March, 300 liters of milk. In April, 320. In May, 290. And in June, he had 270 liters. Now, your tasks are threefold. First is to create a chart to show the trend. Now, I have not mentioned which kind of chart you should prepare. So, you must go back to the module and see how different charts are used for different things, and then select the appropriate kind of data visualization to show this particular trend. Once you have narrowed or drilled down on the particular chart you want to produce, I want you to ask this question: which month had highest production? So your chart should be able to show this intuitively. Now, there is another question for you all to execute. You should also answer the question: is production increasing or decreasing overall? So this is a challenge activity which I encourage you to go through on your own. Now, we have looked at 6 different kinds of charts. We can also do a quick analysis on which charts to use. So the first chart which we saw was a bar chart, and it's useful if you want to compare categories. And then we were looking at a histogram, and then we mentioned a histogram is useful if you want to understand the distribution or spread of your data. We have also given you 2 questions on bar chart and histogram, and I'll sincerely encourage you to go through those. Then we looked across a line chart which help us track changes over time. So if you want to track the dynamics of a variable or how does a variable evolve through different time periods, you use a line chart. It's one of the most simple ways to understand how things evolve over time. If you want to understand how to show parts of a whole, you use a pie chart. If you remember, we talked about the example where you would distribute the family expense, and then you can see which particular expense takes the highest chunk of your income. In those cases where you want to show parts of a whole, you use a pie chart. Now comes the important part or data visualization thing, which is scatter plot. Whereas the rest of the charts only dealt with one single variable or one single thing which was changing, a scatter plot tracks 2 different things. And whenever we are tracking 2 different things, we are interested in knowing the relationship between them. Does increase in one quantity leads to a decrease in another one? Or does a decrease in one quantity leads to an increase in another one? Or do they remain stable? For such cases where you are interested in finding the relationship between different variables, you use a scatter plot. So a scatter plot is where you want to find relationship between your different variables. Now again, there are certain common mistakes which you must avoid. Do not use a pie chart when values don't add to 100%. A pie chart where values don't add to 100% will not make any sense. You cannot use a line chart for unrelated categories. For example, you cannot use one line to track the scores, and similarly on the same graph you use it to track rainfall. So don't use line chart for unrelated categories. Also, do not make your charts too colorful or complicated. We are not interested in making charts colorful because the idea is communication. We want to communicate or condense our numbers into a chart. So do not make them too colorful or too complicated. Keep them simple, which makes communication easier. Always keep your chart simple and easy to read. Keep the titles and labels clean and easy. See there is enough space between your labels. So avoid these mistakes and you will not have any difficulty in creating simple and easy to read charts which are useful for your data visualization journey. Always make your charts more readable. Always add clear titles. Remember, the goal of data science is to make an informed decision. You cannot make an informed decision if your chart does not show what it is about. Always tell the viewer what your chart is about. Always add clear titles. For example, what is this chart showing? Always label your axes properly. So we have talked about x-axis and y-axis. Always have your categories on the x-axis. Always use your y-axis for values or numbers. You can sometimes make x-axis for values but y-axis and y-axis for categories, but try to stick with the convention of having categories on x-axis and values on y. Use simple colors, avoid bright colors. Use a palette which is easy on your eyes. Always add a legend if you are comparing multiple things. So a legend is a small data part in your chart which will tell you what different colors correspond to what different values. Always add a legend if you have different colors and if you are comparing multiple things. Now let's also quickly understand how you can use ChatGPT for better charts. Always try to use good prompts. For example, your good prompts can include make the title bold and larger. Whereas you're not specifying what font size or what font you want, ChatGPT is smart enough to understand you and make the title bold and larger. You can also ask, use different colors for each bar. Or you can also ask, add a grid in the background. Or sometimes if you feel the chart is getting cumbersome, you can ask ChatGPT to rotate x-axis labels for better reading. So what we learned in these particular modules. So we learned why visualization is important in data science, how you can use ChatGPT to generate visualization code. Then we went through 6 different type of charts and when to use each. Then we run the code in Google Colab and created our own charts. The key takeaways are visualization always helps us see patterns that numbers hide. Different questions need different chart types. ChatGPT plus Google Colab make your creating charts easier. And the end part is practice is the best way to learn. Try with your own data. This was our module on data visualization. I am Dr. Vishwas Kukreti. Thank you. Thank you very much.